Good morning, everyone. We'll start the session. We'll start the session in another 5 minutes with the inauguration. Thank you.
ಕ್ಲಾಸ್ ಇದ್ದಾಗ ಆಫ್ ಮಾಡಿ ಹೋಗ್ತೀರಾ?
Good morning, everyone. Good morning, respected this faculty development program. Today we have here to enhance our knowledge, skills, and teaching experience that we provide to our students. We have a jump-packed day with insightful sessions, interactive discussions, and more. So let's make the most of it. So welcome to 5 days national level FDP on emerging trends in image processing using artificial intelligence. So, welcome. So first of all, I would like to welcome our chief guest, today's speaker, Dr. Manjunath sir, Dean Academic, Professor and Dean Academic, Department of ECE, JNC Shimoga. Welcome you, sir.
Thank you, sir. Thank you, sir. Thanks, sir. Thanks.
Next, our HOD, Department of ENC, Dr. Siddesh KB. I would like also welcome you, sir. Now, I would like to welcome our beloved principal, Dr. Bharat PB. Welcome you, sir.
Morning.
Now, a speech introduction about the FTP by our HOD, sir, Dr. Siddesh KB. Am I audible?
Yes, sir. Audible. You can continue, sir.
Good morning, one and all. Yes, chief guest, Dr. Manjunath B, Dean Academic, JNC, and our respected principal sir, Dr. Bharat PB, and all our participants, various colleges, and our teaching and non-teaching staff departments. Today we organized the 5 days national level FTP program on an emerging trends in image processing using artificial intelligence. So as we know that a cutting-edge technology methods are introduced day by day, the artificial intelligence. So that how we are utilizing this artificial intelligence to an image processing here, because we see that image processing is there so many lot of methods are there. For example, the filtration, distortion of image, and the wardrobe marking on the pages, and formations, figure formations. So many such methods are there. So how we are utilizing this emerging trends for artificial intelligence? So as we know that it is a ramification technology, as a such that so many branches are there. AI technology, getting into the image processing. So as we see in the last 5 years back, we're not using much the AI implementation into the image processing, but as a couple of 2 years now, and the recent years, we are using this, applying this methods to a technology, because we are expecting a precision, accuracy in the results, the research results, the experimental results we are expecting, so that we are now the present trending. So what we are applying the artificial intelligence into the image processing. So I hope all the participants and research scholars, faculty members will utilize this opportunity of the 5 days national FDP. I wish you all the best. Thank you, Manana. Thank you, sir. Thank you for your valuable hours. Now I request our resource person, Dr. Manjunath sir, say few introduce about the workshop today's FDP.
Yeah, I hope that am I audible?
Yes, sir.
Yes.
Yes, sir.
Okay. Respected dignitaries, Dr. Bharat PB, principal of this great institute, SJMIT, Dr. Siddesh KB, HOD of ECE department, and coordinator of this workshop, Jaydev RS, Sandeep UR, Raghu S, and IQAC coordinator, Dr. Rajesh, resource persons of this FDP, and my dear participants. First of all, I would like to thank wholeheartedly Dr. Siddesh KB and principal of SJMIT for giving an opportunity to deliver a talk and as a part of chief guest of this inaugural function. And coming to this image processing, It's a not okay, new course, new area, but it's old. But now the advancement in machine learning as well as artificial intelligence, so that makes more okay, more means emerging technology. So and coming to this application, one example I want to give, even in medical field, those who are completed a UG program like MBBS, then they will choose the MD in radiology. So that will be the most demanding MD course. The reason is very simple, okay, because diagnostics, especially using medical imaging and MRI and CT scan, X-ray imaging, ultrasound imaging, so that makes a more demanding course. So hence, okay, there is a lot of opportunities are there due to the advancement in very advanced tools, maybe in hardware as well as software and neural networks and machine learning, all these tools. So that makes the more one. Just I want to give one area of the application, and similarly like remote sensing and industrial automation, entertainment, multimedia, surveillance and security. Okay, so many areas it has a more demanding one. Okay, especially image processing as well as video processing. And coming to the curriculum of our video or any other institutions, we have a one course. It may be elective or course image processing. So if we given to the students, okay, definitely they have a, and even many of the companies, okay, core hardware. I have seen yesterday on website, Synopsys is also working on this image processing. So like there are a lot of advanced, I mean, there are opportunities are there for our students also if we train in a better way. Okay, and there is an elective course you can give it for our 6th semester students. There are many other opportunities like mini project and major project for the second year as well as third year students. If we given the projects especially based on image processing and that to like some of the areas like medical imaging, and that definitely will helps. I think last time, okay, I given some 5 to 10 projects, especially on medical imaging, like disease detection, cancers, breast cancers, lung cancers, and even knee arthritis. Why that knee arthritis? Can we detect early detection? And any suggestions to the doctors? So we jointly we work together. Okay, we are getting that. And even we have one MOU at our Shimoga Medical College, Subaya Medical Institute of Science. Okay, so that so I think okay, faculty can make sure that okay, we can give such live projects, especially those will help for detecting the very advanced detections of any diseases. So this is only one example I am giving. Okay, like okay, so nowadays everything is image based only. Many of even attendance, biometric, many things are there. I think later I can speak, and I think now with the busy schedule, okay, I won't take much time. Once again, I thank entire SJMIT for giving an opportunity. So after this inaugural, again, I will continue. Thanks, sir. Thank you very much. Wish you all the best.
Say a few words about the.
Morning all. Morning all. Am I audible?
Yes, sir. Yes, sir. Audible, sir.
First of all, I would like to thank our management for the permission to conduct this 5 days national level online faculty development program on emerging trends in image processing using AI. I would like to thank Dr. Manjunath P, Professor and Dean Economics Department of ECE, Shimoga. And once again, on behalf of the Institute, I welcome you all candidates, participants. Yeah, as we all know, they left none of the branch or none of the discipline untouched. And in image processing, they have done a revolutionary work. Basically, the trends like image recognition, enhancement, segmentation, text recognition, medical imaging. There are so many trends which are emerging from the image processing. And in the beginning of 2023, I think 22-23, from our medical college only, they came up with a project called collecting data on image processed of retina, eye retina. So as you all know, the data is new gold. We have many things to do, and I really appreciate the effort put by EC department and HOD and faculty for bringing Manjana sir, for sharing their insights on this platform. I wish you all the best. Thank you. Thank you.
I invite Professor Sandeep to introduce our session speaker, Dr. Manjunath sir.
Thank you, sir. Our pleasure to welcome Dr. Manjunath P. Sir, Professor and Dean Academics in the Department of Electronics and Communication Engineering, JNC College of Engineering, Shimoga. Dr. Manjunath holds the PhD in the Wireless Sensor Networks from the IIT Bombay and has an undergraduate academics and administrative career spanning the 2 years of 2 decades. His notable roles including the serving as the HOD of ENC and in-charge principal and a BOE chairman for VTU Belgavi and also a BOE member for VTU Belgavi. Under his guidance, 6 PhD scholars have successfully completed the degrees, and we have honored to have Dr. Manjunath with us today for our faculty development program. Over to Manjunath, sir. Thank you.
Okay, thanks. Sir. I think I shared my PPT. Is it visible to everyone? Okay. I just shared my presentation. Is it visible?
Yes, sir.
Okay.
Manjunath, sir, you can start, sir.
Yeah. Okay, thanks. Okay, once again, I thank SJMIT management, principal and HOD and coordinator for giving an opportunity. HOD and coordinator for giving an opportunity. HOD and coordinator for giving an opportunity. Yes, sir. I will start. And coming to the content, okay, I will not take a much in depth about machine learning or artificial intelligence because other resource persons they are going to cover in detail. Just I want to share very simple thing, basic components of image processing. Those who are new to the image processing area, or they may know but few things. How can we code in MATLAB? Okay, it may be MATLAB or Python. So few things just I want to share. Some of the few basic steps. What is the image? What are all the applications of the image processing? And MATLAB demonstration. How can display the images? How can do some like enhancement techniques? Like one of the pre-processing techniques. Only few things just I want to cover. So introduction about the image processing and application of the few applications of the image processing, and how can we code in MATLAB? Same almost code can be done in Python also. I think better you train your students in Python only because there are a lot of job opportunities in Python. Maybe they studied, but when come to the coding, without application they may not study. I think better you train your students to train or give a task, especially give those who are planning to guide a 3rd year and 2nd year students. You choose some of the areas like signal processing and image processing. Choose some transaction papers or IEEE Elsevier papers. Let the students understand, read and implement through MATLAB and Python. Python, if they did, definitely that will help for the placement. I think this is about what I'm going to cover. So I may not take much time. So whatever I did, those things I just answered. It is very small, very introductory session. Yeah. Yeah, we all know that the field of digital image processing refers to processing of a digital image by means of a computer. Anyway, that is not a big issue here. So very advanced computers with high-end computing, memory, processing, everything is now available in it. And coming to an image, as a electronics and communication. So we consider it as a signal. An image is composed of a finite number of elements such as location and value. Small dot, the elements are referred as a picture elements, and image elements, spells or pixels. Smallest part of an image, smallest point in a digital image is called a pixel. That is how the name pixel comes. Picture element. And a digital image is defined as it is a 2-dimensional function. So usually represented as f of x comma y, where x and y denote the spatial coordinate, and f of is called so this f of xy, it is a value. It has some value for the coordinates x comma y, a gray level at the point of x comma y. And some of the how the image processing usually we will acquire the image. There are many techniques are there to acquire the image. And usually the next step is the enhancement. Okay. The basic step is the enhancement technique, some of the image enhancement technique, and restoration, color output, some of the times wavelet, and a few areas we are going to compress, morphological processing, segmentation, object recognition, like it has a many such applications here. And divided into, like I told, n rows and m columns. The value assigned to every pixel is the average brightness in the pixel rounded to the nearest integer value. Nearest integer. The process of representing the amplitude of the 2D, the signal at a given coordinate as an integer value with L different gray levels is usually referred as a amplitude quantization or simply quantization levels, as usually represented by m cross n matrix. Means how it is stored in a computer. It is stored as an array of a two-dimensional array whose elements are in 0 to 255 corresponding to the brightness scale. So like that. Okay, this is the one sample here. And representation, how it is represented and how it is stored. The element of the matrix is called an image element, picture element, or pixel. That is f of xy is equal to 0 to like 255. 0, 0, 0, 0, 1 means it is a m cross n matrix. And while accessing, okay, in C and all, the index start from 0, 0, but MATLAB it is index from 1, 1. Okay, so f of 1, 1 will be the in MATLAB case. So because 0, 0, okay, indexing is not there in a MATLAB. And coming to the color, okay, how that color is stored in any, okay, your computer or in mobile. Okay, there are three mirrors like RGB and lenses. It pass through this, and it's stored in a three arrays like red one matrix, green another matrix, and blue. It is a filter here, incoming light filter, like it only allows the blue content, green content, red content. In this way, any picture when we taken through camera, it will be stored in this way. Yeah. And primary colors are, as we know, red, green, blue. And each primary color component is separately stored like 3 into m cross n. Means 3 m cross n is the actual array. For each color, red color, there is a m cross n, green. So in that way, it is a 3 into m cross n. Color size is, means when come to the gray level, it is a 3 times higher than your gray level image. Constructed from, and all colors, okay, it may be, while displaying also, the combination of RGB will makes the color. Means each intensity is projected through a color filter like red, green, blue to create a monochrome image. The intensity maps are overlaid to create a color image. So this is about your colors here. And how actually the images are stored. So only few things I have taken here, and some of the other formats also there, but most familiar formats of the image, those are stored in computer are TIFF format, .bmp, .gif, .jpg, .jpeg 2000 also is there, PNG, and MPEG, .mpc. So like different formats, when we take the photos, okay, through camera, any sensor, it will be stored in these formats, and will be, if any formats also there, we can convert into these formats. And color, okay, then when you come to the processing side, we are going to take the color image. Sometimes we are processing a gray level. Some of the applications we are going to process in a binary image. Okay, so that's why we have to convert color to gray to binary. So again, back to that also sometimes we are doing. And some of the how actually the images are captured. So there are sensors. It may be optical, infrared, ultraviolet, X-ray, radar, MRI, ultrasound, and micro. So these are all the sensors will capture the images. While coming to the X-ray, radar, MRI, so these are related to the this especially medical field, and others also will be depends on the applications. And satellite, like where actually we are going to take microscope, X-ray film, and MRIs machine. So using these platform, we will capture the images. And these are the some three images that I am displaying here. This is a color image, and converted into grayscale. Again, this grayscale just I converted into binary, that is a black and white. And most of the processing is done in binary format only. But some of the gray level also we are going to detect some of the features. And coming to the application, it has a wide variety of applications. And we may be knowing that, okay, as of now, okay, many movies and all, okay, they are using this image processing. And some of the cases we have to restore and enhance the images, like satellite images and very blurred images. So this is the second application. And as of now, okay, it is a communication is multimedia. So audio, video, okay, all pictures and everything we are exchanging between the two users. So in transmission also we have to encode and decode and even compress. In that area, okay, again image processing is used, and pattern recognition. Some of the cases 3D, okay, and animations side also we are using this, and color processing, register techniques, video processing. Very common is we are observed is a biometrics, finger detection, face recognition, object tracking. Yeah, this is very okay, regularly used, okay, areas, okay, as of now commercialized also. Vehicle detection and monitoring, traffic detection, motion detection, many, okay, these are only few areas I just mentioned here. And like one a few examples, like where the medical MRI and all CT scans they have taken when they go for an in-depth, okay. And so nowadays, okay, most of the doctors without any these are testings and scannings, okay, they won't treat, okay. First step they will write it for any diseases, because without any testings, no one doctor will judge what happened. So especially when come to the some of the like spinal cords, knees, and some of the diseases, they will refer for like taking X-rays, MRI, CT scans. They will suggest, okay, these are the images. And the last 3 years, okay, I just given some of the project to my students to work on this, especially medical field, because as a engineering students, if we help to the doctor, that may helps. Even I jointly work with a few doctors to solve some problems. And robot vision, okay, yes, okay, it is not a new, now everything is automated, robot vision, and remote sensing also, satellite images. This is has a, okay, most of the ISRO and all, okay, they are doing, okay, urban development, road, okay, everything, okay, forecasting, weather forecasting, for everything, okay, that based on these images, they can use these are the some of the areas of remote sensing. And this is something like identifying the leaves based on these structures. Just okay, when we scan that leaf, which tree this one. So like many, okay, even iris detection, a simple one of the biometric. This is the one more biometric. You even come to the PCB manufacturing, okay, no one can identify there is a defect or some of the component is not inserted. Some of the missing components easily identified by image processing. Yeah, I think, and even industry automation, when any company that going to be manufacture some of the bottles like the tape, it is not properly filled, easily it can be detected. Even cap of the bottle not perfectly filled up, okay, everything, okay, automated here, okay. So like, okay, just I have shown this few examples here. I think beyond this, you can search, Google and all, okay. There are plenty of application or live projects also there. You can work out with those things. And coming to this MATLAB, okay, how to start, okay, those are really beginners, okay, doesn't know anything about the image processing. Better, okay, choose the platform of MATLAB, because Python and all, okay, needs some adding some of the libraries. And again, which platform to work, okay, that will be the some of the, I think it's difficult. I hope that, okay, this I think will help. Few commands just I want to show, and parallelly I just cover some of the image enhancement techniques. And most familiar command when image comes means MATLAB should have a image processing toolbox. It should, okay. Usually most of the colleges they have taken a yearly wise license. Most of the they will be built in those things. Like one command is the this is about the introductory, how to start yeah, image processing is good. How can we train our students and how to start the work in image processing? Really, is it possible to implement in the practically? Can we verify? Can we do some of the things? Yes, okay. Start with the MATLAB. For example, you have some image, you want to read it, okay, and write it and show it, display it. There are a few commands, I am read, I am writes, and I am show. One command, okay, just I is equal to I am read lena.bmp. I will, okay, download one lena one image, and this is the color image. I want to show, the command is I am show of I. Even I can just show it in MATLAB command also. Because of the timings, okay, I think just I will go through. Yeah, and even you required, okay, I will share the PPT in that group. You can later you can use. Very simple command. Why I okay insist you to start with MATLAB and all. Python, okay, you please okay instruct your students to work on Python only because they can that will helps for the placement. Yeah. Some of the things, okay, what other commands? I told, okay, color is there, gray, and even binary image is there. How can we convert? What are all the simple commands? Because many of the applications, okay, we're working on a binary images only. So when that comes binary, I'll okay stored it in one matrix. Okay, that is a two-dimensional array A1. It stores the content of the Lena, like 0 to 255 in RGB format. Just okay, I use the command I am show A1. So that displays the color. So am I audible? Okay, I don't think, okay, it's okay. Everybody is audible and will be whatever I have shared the screen, is it visible to everybody?
Yes, sir.
Okay. Yes, sir. And this is about the command I have read. So just we'll read the command show. And the next command is converting this. So why I am showing all these commands means simple to learn and simple to guide the student. And if you are anybody is doing a research work on image processing, yeah, this will be the fundamental things. And this will convert, this command will convert to the color to the gray. Yeah, I displayed here. This one I have displayed. Similarly, I want to convert into black and white sim IM to BW. Then after that, okay, that A1 and A2, A3 are the some two-dimensional array. There I have stored the content and I am show of the A3. So in this way, simple commands we can use here. And to feel, okay, how actually gray. So what is the meaning of the gray? If you want to understand that, for example, A is a one matrix and it starts from 0 to 255. That is means 2 to the power of 8. Okay, each pixel is of 8 bit usually, and 0 to 255, 0 to 255, first row, second row, third row. This I want to generate and I want to display also. So where at 0 it is a black here. I think my cursor and all what I am showing, I think it will be visible in your cursor. This is the 0 and this will be the 255. At the right side of the corner, okay, this will be the pure white here, okay, black and white, okay. This is a shade, gray shade here. How to create means if you want to feel the grayscale image, the meaning here, just I created one array here. I is equal to 1 to 255, j is equal to, this is the one array, and a of ij, where a of ij is equal to j minus 1, means 1 minus 1, it is a 0, like up to 255, means here, okay, I'm a of 1, 1, 0, a of 1 to 1, a of like 1 to 2. So like that, okay, I'm just created here 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, when I is equal to 2, second row. So this is the array I have created and it is stored in a. I'm sure then it will be stored here, okay. In this way, you can feel, okay, how the grayscale image really, it is created. This is the code, okay, simple code, MATLAB code. And if you want to create draw a one circle here, and this what actually I want to show you, how can we create a one black and white here, okay, with a circle, okay, and the circle, okay, it is a radius, okay, x square minus y square like that, something like that, okay, I used here, and the b of ij here it is a image, it is an image here, b of ij of 256. So entire size is 256 of radius, 80 pixels, centered around 128. Means I want to draw one circle, okay, and I want to display arrow, and to feel the coding. Okay. Here, what I want to show, demonstrate here, how to code, how can we write the MATLAB code, and how can we display the same in the image here. Okay. And again, it is a loop here. I and j are the okay, and distance is what I mentioned here. I of minus 120, j of minus 120, and square root here. Square root adjusted into the power of 0.5. And whatever you calculated here, if it is less than 80, then it will be of a white here. Okay. Otherwise, it is a 0. Means this distance is going to calculate the value. So that will be checked here. If distance is less than 80, whatever the value it is clear. For example, when it is initially start with 1, so then it will be it is simply 0. When ij is 1, 2, 3, like it will be simply assigned as 0. And when it will be less than or equal to 80 within this, it is going to make it as a 255 value. That is a pure white here. And after that, it is displayed. So this is about how can we create some of the images and feel the coding. And similarly, how can we display some of the cases? What happens? Sometimes, okay, we need a green color of the image. What is the pixels of those green color image? Sometimes we need a red, and sometimes we need a blue also. Yeah, can we convert that? Okay, given especially image processing side, sometimes, for example, vegetables and all, identification of a particular vegetable based on the color. For example, green, okay, you can not a ripened. If it is a something like red, you can, or yellow, you can decide as a ripened one. Like some application, we have to convert the images into different format like red color, green color. And this is about the code I have written here. This is about the original EM. Then I created a one array of 2 cross 2. 2 cross 2 means 1, 2, 3, 4. So in this array, I'm going to display first image, second, third, fourth. And how to convert, these are all the codes available in the internet also. Or you can, means you want to code, okay, you want to convert the image into different planes. Yeah, that is all possible here. Then next come to the first step, okay, usually we call it as a pre-processing. That is the first step of an image processing. So you can ask your students to identify what do you mean by pre-processing, okay? So they are going to do some things, okay? That come to the first step is image enhancement. What do you mean by image enhancement? Modifying the intensity of a pixel of an image so that it can be more suitable for a specific applications. I will show, because few applications I will show. After enhancement, what happens? And different enhancement process suits for, means some of the times, okay, that enhancement, okay, different enhancement techniques will be useful for some applications based on the applications we are going to do the enhancement. Yeah. Coming to the enhancement, there are two methods. One is a spatial domain and frequency domain. A spatial means a pixel directly we are handling the pixels itself. Means each image is, okay, stored in the format of a pixel. Okay, pixel it means in terms of bits only. So 8 bits. Okay, usually each pixel is represented by a 8 bits. So we are going to directly handle, okay, enhancing directly by the based on the pixel value. And in the frequency domain, we take the Fourier transform, then we do some processing, then we can, means take the Fourier transform, take the inverse Fourier transform. Frequency domain, okay, will come but take on the inverse frequency. So that is also, these are the two usually methods that are used. Okay. And before going to that, okay, just I want to show histogram is one of the most familiar histogram. I think you may be knowing that. What, okay? Indicator of image contrast. The histogram for digital image with the gray level in the 0 to z discrete function. For example, I hope that, okay, this will be the visible image. This is a grayscale image. Its pixel value varies from 0 to 255. What actually histogram? It gives the x-axis and y-axis. X-axis is the gray level value. This is the x-axis is gray level like 0 to 255. What about the y-axis? how many such, for example, one pixel has a value of 100. How many such pixels are there in this image? And some of the pixels have a 0 value. How many such pixels are there in this image? Some of the pixels have a pure white. How many are there? Okay, this is the plot here. So what the histogram? The histogram of a digital image with gray levels in the discrete function. The h of rk is the nk, and where rk is the kth gray level. Kth means where nk is the number here, number of pixels. N is the total number of pixels in the image. So we start from a 0 to L minus 1. And even we can normalize this also based on the N. And I'm plotting the histogram. I will tell you why this histogram comes here. Histogram is also there. One I have just taken the image red, and 1 comma 2 comma 1. Okay, what this command is, it is a plotting with the 1 row 2 columns, 1 row and 2 columns. In the first, this one I'm just displaying that original image. Then I'm taken the hist is the built-in command here. im hist is there of I comma 50. So how many levels you want? Okay, that is there. Histogram. Okay, this I am histogram I am plotting here. So that is plotted here. Subplot 1 comma 2 comma 2 I am missed. Okay, 1 comma 2 comma 1, it is the original image. Its corresponding histogram just I am plotting here. I will explain okay what is the histogram and all. And similarly, okay, these are the histogram of an image you can display in bar. Okay, different formats also you can display here. And what is the application here? Okay, one of the application histogram, and we will see. I hope that okay, I'm audible and all what I'm showing it is visible to the participants.
Yes, sir.
This is about the original image, and this is taken. Okay, means you can say it is a raw image. When we displayed the histogram of this, okay, because most of the content in this nearly okay black here. So you look at that. This is the what the x-axis. It is a pixel value. So means that is the 0 to 255. What is the y-axis? Number of such pixels. Okay, how many are there? For example, pixel value is 10. So these are the number of such pixels are there. So when I just plotted the histogram, so this is the one content here. And when okay, histogram equalization is a technique, means equalization is also the technique that allows the image to take all grayscale values nearly equal, done by mapping. Okay, means when I done histogram equalization, so when I done histogram equalization, you look at that. Okay, these are the shades visible. Means so these are all simple steps in image processing. And when I just okay plot this is the histogram here. Okay, this is the command. Okay, just read that image and subplot here. Means 2 cross 2. It is a 4 division. First okay, first element. First okay, this is the image original. Corresponding histogram. And when equalization done, how okay it is done. Okay, im hist is the histogram of that pixel. Then title histogram of that. Then hist eq. Okay, hist equalization. When I done it, okay, this will be the image. I'm just plotting here and corresponding pixel, okay, histogram of this image. So in this way, even histogram also is one of the technique, okay, for the pre-processing, especially image enhancement. Next comes to the edge detection. Okay. Most of the time, okay, the very important is we want to detect the edges, okay, even character recognition. Many of the applications, the entire image may not be required. Only some of the features of the images are required. That is the edges. Edge is also one of the most important feature. Based on that edge, okay, we can detect this is an object like that. How to detect an edge? So there are different operators are there. I think all electronics and communication and even computer science, they may be knowing that, okay, convolution operation, how the convolution is done. Okay, convolution is there. Multiplication and convolutions. These are the operations you may be knowing. What actually edge represents the direction of the most rapid change in intensity. Edge detection contributes significantly to algorithm for feature detection, segmentation, and motion analysis. Edge strength is given by the gradient magnitude. The gradient is means how this mathematics helps us. In the x and y direction, that is a del of I comma xy is del by del x of I of x, where x is the image, plus del by del y of I of y. And these are the most familiar operators. Other operators also there, but Roberts operator, Prewitt operator, Sobel operator. These are the gradient operators used to detect an edge in an image. These are the different ones. Yeah. Roberts operators in -1, 0, 0, -1. And this is a horizontal operator, and vertical operator -1, 0, 0, -1. Prewitt operator -1, 1, okay, like that, okay, it is there. Sobel operator is there. Yeah, different operator there. And you look at this, okay, when we, for example, this is the image I have created. I just want the edge, okay. I don't want anything here, okay, because other parameters may not be required, or I want to store it, okay. So I want to compress it and store it, or I want only some of the features like edges, okay. What is the edge here, okay? I want to find out. Just I operated, and this is an horizontal operator. When I, okay, what operator means, what actually it is doing? It is a convolution of an image, of an image with these operators. So means X, I have one image A. With that image, I am convolving with the operator. This is a horizontal operator, and this is a vertical. Similarly, Prewitt operator, Sobel operator. When I did this operator, so when a horizontal operator I did, you look at this, okay, variation. Okay. At this point, no changes, okay, almost, okay, there is no much change. But when I come at this, okay, other things, okay, it is a black and white, black and white. Here, there is not that much variation is there. So that's why I'm getting here 0, 0. When I same thing, I did it vertical operator, and at this point of view, there is not that much changes here. That gradient operator, I did it, okay, it did not change. So when I mixed up these things, I am getting horizontal. When I did both operations, I am getting a edge of this image. It is a simple circle. Yeah. So in this way, we can use the operator to detect an edges in an image. Yeah, for this also I written here. This is just create a circle and a convolution of operator -1, -2, -1, 0, 0, 0, -1, -2, -1, 0, 0, 0, 1, 2, 1. So this is the horizontal operator. Yeah, -1, -2, -1, 0, 0, 0, 1, 2, 1. Convolve with this image B with the K. This is the convolution. H1, then, okay, we'll take the, and H1 is V dot H. So when we did E, I am getting here. Means horizontal as well as vertical. Both we did it, okay. And then adding that means when I did horizontal operator, vertical operator, after these two, when I'm adding here, I'm getting that. So means I am shown. So this is the original image, horizontal operator, vertical operator. Yeah, means how to start the coding in your MATLAB. So in this way, you can start. And the next one is the Sobel operator. So this is the operator. Using this operator, just I want to find out the edges here. So you see it, okay? These are all the while just I operated. I just again what happens? This image is ready. Then convolve with the Sobel here. This is the operator, Sobel operator. When I did it here, this when come to this only because I don't want anything. Okay. For example, what is the number? It is there. What is the figure? It is there. What picture? It is there. So some of the cases only I need some of the features like edges. How to extract the edges means in this way I can extract that. And then Roberts operator and Prewitt operator and Canny, okay, different operators also there. In Canny, okay, many of the edges are visible. Okay. Different, I told, okay, depends upon the operator. While Canny is much better, it will give all the edges of an this image. I hope that it's visible in your mobile phone or your laptop. How this, because when you are looked at the mobile phone, it may not be good, I think, visibility. But if you are watching through your laptop or desktop, visibility, all these things, whatever I am showing, will be visible to you. Yeah. So this is about the Canny operator. Same thing, I written here, reading the image, then different operators like Private is the built-in, Roberts is also built-in. Many of these operators are built in your MATLAB here. The I means do, detect an edge with an image I, operator, Private operator, Roberts operator, Sobel, Canny, then display. So for this, whatever I have displayed, for this is the code. All these codes I written in the using MATLAB. And next comes to the filtering. So these are all some of the times we can say that it is all pre-processing. Removing or intensifying some of the components means before going to the any machine learning and all, these are the steps required. And if we have any raw images, and while we did it, only the content of that image is visible, and you can make some experiments or give it some of the assignments to your students so that they can submit it. Those who are handling some of the subjects like image processing and signal processing. And the spatial filtering using some of the masks here, using the Fourier transform, like methods for filters. This is the mask here. Our matrix is convolved. Kernel also we are going to call, or window, we will call it as a window or kernel. So we will operate here. This is of a 3x3. W1, W2 are the values here, like what I have shown, Sobel, Canny, and all those things. And some of this will be is equal to WA Z this H and Z. These are all. For example, this is a virgin image. I added a pepper and salt noise to this. For example, this is the original image. How can we remove the noise? Yeah, by using an average filter and median filter, we can remove the noise. This is actually original image. I added some noise here, and how to remove and how can get back my original image. And code for this one is, and salt and pepper means add a noise to this original image, add a noise to the original image, salt and pepper, then use some of the filters to remove this noise. Averaging here, averaging I done here, and average filter, median filter. This is average filter, median filter. We can remove the noise. Means these are all comes under the pre-processing of an image. Yeah, this is the code. And come to the frequency component. I told, there are two methods are there. One is frequency domain and one is the spatial domain. And coming to the values measured, an image is a 2D array, I already told. Brightness along a line is a set of values measured at spaced. And each of these frequency values is a frequency component. And large values at high frequency component means what is that large value of the high frequency? So that is an edge here. Or when it is a low frequency, it is a smooth area when come to the images here. And what is the meaning of the enhancement? Modify the intensity. Different enhancement processes are there. And I already mentioned, some it may be applicable. Yeah, so there are two methods, spatial domain and frequency domain. In both we will see. And convolution in time domain, we already know. These are the things. F of xy, g of xy. F of xy is the original image, that is the input image. H of xy is the what you want to convolve. So that is the convolution operation. How it is done means in this way, where f of xy is the input image and g of xy is the convolved or filtered image, and h of xy is the filter. So, and also we know that convolution and frequency domain is simply it is a multiplication. Convolution domain is multiplication of frequency domain, and that means easily we can implement. Means why we are going for a frequency domain? because it is easy, simply multiplication. So that's why we will take one domain to the another domain, time domain to the frequency domain, or spatial domain to the frequency domain, because easy of a operation. Yeah, and then how it is done. I have some few slides. Okay, I think another 10 minutes. I think 10 to 15 minutes. I will complete my presentation. Sandeep, is it okay? Another.
Yes, sir. Okay, sir. No problem, sir.
And I think visible also slides and
Yes, sir. Yes, sir. Everything is perfect, sir.
yeah. And coming to them, what actually the filtering is done? Okay, what are all the steps in frequency domain? These are the simple steps here. Why it is simple? That also I will tell because of the MATLAB. Python, it may require some of the adding some of the tools and some of the commands, but that definitely helps for the students because most of the companies they are asking for at least one coding C or Python. C is much more difficult. Python is not that much difficult. So that's why I'm also mentioning the entire whatever you did it in MATLAB, convert that or work with Python so that helps. Okay, how to start with coding in a Python. Read the image and compute the frequency domain, convert that into frequency domain. Multiplication, it is a convolution, means operation is done by a multiplication. So what I done, spatial domain to the frequency domain, do the operation and take the inverse DFT, whatever you need to obtain the actually. So what this step is do, this is the filtering here. I same thing. Okay, if I did it in a spatial domain, it takes a lot of time. Means convolution operations. But in frequency domain, just as a multiplication. In block diagram also, I'm showing here pre-processing, Fourier transform, and convolution. This is the third step here. Okay, convolution, and fourth step is inverse post-on. Means you will get back your original image, enhanced image. This is in block diagram, and these are the steps. And these things also I will show it using MATLAB code also. And mathematics, come to the mathematics, we all know that what is the Fourier transform of an x. F of x is your time domain or spatial domain signal. F of u is integration minus into f of x e to the power of. And when we take to inverse Fourier transform, f of x is equal to whatever this frequency domain f of u. And in a discrete format, these are the equation for a one domain of a single. And I want to show how this time domain and frequency domain, one sample code I just time show. You look at this, I think visible. I just plotted a one sinusoidal. These are the 5 cycles are there in this. This is about the 5 cycles. And I want to find out the frequency of this signal. How many frequencies are there? What is the highest frequency component of this sine wave is made? I want to find out how to do this. Okay, so I will take this signal frequency domain and I measure, and I will get to know. Yeah, converting this signal into frequency domain. Why I am showing this slide? How to operate time domain and frequency domain. For that purpose, this is the code here. Just plot this signal. This is for plotting here. Some signal OF is equal to means 5 cycles here. There are 5 cycles here. Just I plotted with the color as a red here. Then after that, I taken the Fourier transform. That is here FFT of x. FFT of x with NMFT means how many points FFT we want. These are all built-in command. There is very advantage, and there is a we have to take the absolute of the text because it has a both because we need only the absolute value of this signal. I have taken here. Then after that I plotted here. You observe here what is the axis here. This axis is a frequency, and how many cycles are there? 5 cycles. 0 to 10. Okay, it is showing. Okay, it is a 5 frequency. Yeah. Yeah, in this way you can understand the time and frequency domain. Yeah, for this also, the square wave is made up of many sinusoidal signals. usually sinus, the square wave, okay. We all know that, okay, how this square wave is created. A combination of many sinusoidal signal will give the square wave. So how many such frequencies are used sinusoidal? One is a 5, 15, like combination of these all sinusoidal frequencies gives the square wave. And those who are know the properties of the Fourier transform of the square wave, Fourier transform of the sine wave, and how many what frequencies it is made up of. Okay. To understand these mathematics as well as signals, you will get to know. Okay, so this is the thing I'm just plotting here, and yeah, inverse. Now, okay, we'll come directly because image processing it is a two-dimensional f of u v. This is the formula, and about this one, because all our content is a DFT only, because pixel values are in discrete. This is about the DFT, and this is about the IDFT. And these are all the commands built in image processing. Digital filters, low pass filter, high pass filter, and band pass filter. All we know that, okay, we taught to the students in image processing also, and how actually applicable in a image processing. Some of the application we are going to use a low pass filter, high pass filter. Sometimes, okay, we are going to use a band pass filter. It is applicable for signals as well as image processing also. And we will see the ideal low pass filter, Butterworth, and Gaussian low pass filter. And yeah, this is the U naught here, okay, then or D naught, you can say it. Only these frequencies only you allow, remaining and all do not allow. So the his h of uv is equal to 1 for whatever you have your signal, two-dimensional signal d of u comma v less than or equal to d naught, make it as a 1. Above that, make it as a 0. You know, yes. So that, okay, I just created a one circle here, something like that. That is the thing. Entire thing, okay. The code for that is 0 to 255. Then find the values here and UV. Then apply the FFT and IFFT back, okay, so that you can display. This is the three-dimensionally how it is visible. That command is also it is the mesh of H2. That command you can use to display this. So just I want to show the low pass filter. It will allow the filtering of a low frequency component only. Yeah, this is the code, and different filters also there. Butterworth filter. This is the function of h of uv, where how you generate what actually your image is. This is my image here, d of uv. So d of uv is the image. For that image, I want to pass it through a filter of a Butterworth filter. This is my image d of uv, and this is the function of a Butterworth filter. And I want to pass it through this filter. How it looks. First, I created that image. Then this is the filter function. What the filter function? 1 divided by 1 plus d of uv is my image divided by d naught to the power of 2 into n. N is the any number. Okay. So h is equal to 1 divided by 1 plus d of uv is my image. Here it is my d. It is my d, means it is a circle I created. How to create a circle already I have explained. D by d naught, d of uv by d naught to the power of dn is the d naught I am going to specify here. The enter the value of n I will enter, and d naught also I will enter, and different values I can give and display here. So this is about the Gaussian filtered image. And this is about the MATLAB code, like different also. And similarly, high pass filter, same thing, but this D naught is in this case only circle, okay, means all high pass filters, okay, remove here. Yeah, MATLAB code for this. Butterworth high pass filter. This is about the Butterworth high pass filter. This command, okay, whatever the function of a Butterworth filter is there, just I implemented here. Then I have taken the FFT of this H. Then I have displayed here. Okay. This is the image and corresponding 3D. 3D is mesh grid. What is the command here? It is a mesh grid. Yeah. And the Gaussian filter. Similarly, create an image, this image, pass it through a Gaussian means in this way, okay, images are here. You look at this, okay, Butterworth filter, low pass filter, ideal high pass filter, and this will be of a Gaussian low pass filter. Yeah, like that, okay, we can use some enhancement techniques here. And I think these are all that given in your textbook, image processing textbook. I told, okay, D0 value, when I go on changing the D0 value, here is the low pass filter and high pass filter, ideal, Butterworth, and Gaussian. Ideal, okay, when it has only two values, 1 or 0. But this will be of a smoother one here. 1 plus, this is a Butterworth and Gaussian. I applied all these things for different D0. You look at this, okay, this is the original image. When I passed it through a D0, again, okay, with the different D0, means different filtered values I used. This will be the final image. Yeah. So in this way, you can use it, okay. Butterworth high pass filter, low pass filter. Again, different Gaussian filters you can use. Okay, I think this much is sufficient. Okay, for initial remarks. Okay, I conclude, okay, my speech with these things. Okay. These things, okay, I can share with code also. I given simply copy and paste these codes. You will. These are all the examples. Okay, Gaussian high pass filter. If I did, what is this code? Okay, this is the image, and after this, reading an image and passing through the filter, how it looks, all these things. Okay, I think, okay. Now, okay, I close my presentation. And once again, I thanks all the audience. Okay, those who are patiently listened and watched my presentation. And once again, I thank Mr. Siddesh, coordinator of this FDP and principal of SJMIT and management for giving an opportunity to share. Any further, okay, we jointly again work continuously. I can conclude. Sandeep, this is my presentation. Thanks.
Thank you very much, sir. Sir, some of the participants are asking you slides, sir. Sir, if you give us, we'll share that with all the participants, sir.
Yeah, I will share.
Okay,
Yeah.
thank you, sir.
Any
queries?
feedback? Any feedback from the audience? Okay, those who are participating. Okay, you can ask whatever I know. Okay, I can answer it. And my research areas: signal processing, image processing, and sensor network. These are the areas I guided to my students. Few students are done even signal processing also, medical image processing, medical signals like ECG, EEG, and those are the areas what, okay, I guided. Any doubts? Okay, anything is there, and even any technical some requests are there, you can contact through my email ID or my WhatsApp number. Any queries are from the audience? You
If
can
any
ask.
queries, please unmute your mic and you can ask.
If
So
it
thank you,
nothing
sir.
is there, we can close the.
Okay, sir.
Yeah.
So 1 second, sir.
Hello. Hello, Manjunath sir. Hello.
Hello. Audible. You are audible.
Sir, you have given a wonderful session and valuable concepts on image processing and its applications. Hope all the participants are facing these concepts in the future, their research work or the presentations, whatever in coming days. So I thank you for the valuable suggestions given by the Thank you, sir. Thank you.
Thanks, Siddesh. Thanks. Okay.
All
the best.
The feedback
Wish you.
link, thank you, sir. The feedback link is shared in the chat box and it will be open for 15 minutes. Please fill the feedback form within 15 minutes. And next session will be at 3 p.m. And Zoom will be open at 2:30. And the 30 minutes tolerance for the admission.
My suggestion, I request all of you, please attend the afternoon session because he is the one of the wonderful resource person in our college. He did a lot of work and he developed a software for our college. One of the most eminent person in our college. Don't
Dr.
miss
Chetan,
his
sir.
presentation. This is my request from my side.
Okay,
Chetan
Dr.
KR,
Chetan.
he is a
Dr.
HOD
Chetan.
of AIML. Yes. Yes.
Thank you very much, sir.
Yes. I will exit from the meeting.
Okay, sir. Thank you.
జల్దిగా స్టార్ట్ నాకు ఇల్లే
ಆದ್ರೆ ಬಿ ಫಾರ್ಮ್ ಮಾತ್ರ ಒಂದೇ. ಬಿ ಫಾರ್ಮ್ ಏನ ಇವಾಗ? ನಾನ್ ಬೆಳಿಗ್ಗೆನೆ ನೋಡ್ದೆ ಬಿಡ, ನಿನ್ನೆ ಸಿಕ್ತಲ್ಲ ವೀಣನ್ ಇವತ್ತು ಐತೇನೋ ಎಕ್ಸಾಮ್ ಇದೆ ಅನ್ಕೊಂಡೆ. ಆಮೇಲೆ ಅನ್ನಿಸ್ತು ಮೋಸ್ಟ್ಲಿ ಚೇಂಜ್. ಜ್ಯೋತಿ ಸಿಸಿ ತಗೋತಾಳ ಅಲ್ಲಿ? ಏನ್ ವೀಣಾ ಇದು? ಶ್ವೇತಾ ಬಂದ ಫಸ್ಟ್ ಹೇಳ್ಬೇಕಂತ. ಅಬ್ಬ ಏನ್ ಲಕ್ಷ್ಮಿ ಕಲಾತರಂಗ ನೋಡ್ಬೇಕು, ಬಾಟ್ಲ್ ಹೊಡಿಯೋದು ಬಾಳ ಚೆನ್ನಾಗ್ ಹೊಡ್ತಿದ್ಯಾ. ನನಗ್ ನೋಡಿ ಲಕ್ಷ್ಮೀಶ ಇದು ಅನ್ನಿಸ್ಬಿಡ್ತು. ಇದು ಲಕ್ಷ್ಮೀಶ ಅಂತ. ಕಲಾತರಂಗ ಚೆನ್ನಾಗ್ ಕೊಟ್ಟವ್ ಪ್ರೋಮ. ಗುರುನಾ ಎಲ್ಲ ಎಡಿಟಿಂಗು?